Okay, here's a little math humor. Why can't your nose grow to 12 inches? Because then it would be a foot. Get it? All right, let's move on. Welcome to lesson 1.2.2 review and preview. As I did with my last video, this one I will also have the work on the screen instead of walking through every problem because there are so many problems. So let's just jump right in. All right, this is 1-84 and it says use any method to find the points of intersection of the following two functions. And so what I tend to do on ones like this is I tend to cross out the f of x and I put y equals. Then if they both equal y, they equal each other. And so that's what you see here, is I've taken those equations and set them equal to each other. I have subtracted x squared and I've subtracted 5x and I've added 3, which gives me this function here. Then I've used the diamond method, which I've talked about in many videos. My a on this equals 1. B equals -8 and C equals 7. Well, A times C is 7 and B itself is -8. So I have to come up with two numbers that multiply to 7, add up to -8, which you see here with x minus 1 and x minus 7 as the sets of the values in the parentheses. So that means that x equals 7 and x equals 1. And then you'll see here what I did next is I plugged in the 1 into both equations, which solved for a 3. So that means one of my points is 1-3. And then I plugged in 7 to both of these equations here, and I got 81. So that means at 1, 3 and 7, 81, we're going to have intersections. So let's take a look at the graph. And you will see here, if I circle that here, there's your 1-3 and your 7-81, and that helps prove the intersection points for both. And let's move on. Okay, this particular problem, 1-85, just says solve each equation for x. This is pretty straightforward basic algebra, but let's take a look at what we've done here and talk about potential mistakes. So potential mistake on this one is that you forget to distribute that negative to both. That's why you see a -7 and a plus 4x. So then it's just basic algebra all the way down to x equals -6. And that solves part A. Part B, you will see that I used cross multiplication, which when you have two fractions set equal to each other, that's the easiest way to solve it. So I've got 5 times x minus 4 over here, 7 times 8 minus 3x. And then it's just basic algebra again down to the bottom. Now, this takes you down to where x is approximately 2.92 if you're rounding it. But also to get from here to here, you can go on a Texas Instrument and type math. And then you type fraction, which is, I believe, 1. And then you hit enter, and it reduces the fraction for you from 76 over 26 to 38 over 13. And that's it for 1-85. Let's move on. 1-86, make a complete graph of the function f of x equals the square root of x minus 2, label its x and y intercepts, and describe its domain and range. Pay really close attention to where that minus 2 is. Is it under the radical or is it outside of the radical? So let's show the graph. Talk about why that makes a difference. Okay, you'll see here that we are down on the y-axis with the y-intercept, so it's down at -2. That is because when it's outside of the radical, it is a vertical translation. Okay, let's show what a horizontal translation looks like and how a common mistake can happen where your graph changes. So if you are someone who has put the -2 under the radical on accident, you will get a different start for your graph, because when it's under the radical, it's talking about a horizontal translation. So you need to be careful. So this is more like, hey, this is an error that could possibly happen. Now let's take a look at how we found our x and y intercepts. If it's an x-intercept, it's going to have the 0 in the y. Okay, so I just substitute a 0 in for the y, or the f of x in this case, and I solve. So I add 2, and then I square it because I'm trying to get rid of that radical. Okay, and so that means I have 4, 0 as my x-intercept, which it shows up here. Then the y-intercept is different. So the y-intercept means every time you are looking for the y-intercept, x has to be 0. So I just plug a 0 into the radical, and that gives me -2, which shows you our 0, -2. And that's the radical. Now let's take a look at the table. Okay, and if we're talking about domain and range, it's kind of important to notice here that we can't go into the negative territory. So our domain, because we can't have a radical with a negative underneath it, so our domain is from 0, and I was going to put it in interval notation. I'll just do that and I'll show you. Okay. Because 0 can be part of the solution, there's a bracket around it, but CPM will have you say x is greater than or equal to 0. Okay, that's domain. The range, if I was doing the same thing, it would be at -2 with the bracket, because that's the lowest y value, and to positive infinity if I was doing an interval notation. CPM will say y is greater than or equal to -2. And that kind of is the difference here. So for domain and range there. And you'll notice the undefined here. That undefined is really important because that does help you set the domain and range restrictions that you need. So that is all you needed for this particular problem. Let's move on. So I like word problems like this. This is 1-87. I like to draw diagrams and illustrate it because I'm a visual learner. But write and solve an equation or a system of equations to help you solve the following problem. I only wrote one equation, but you're going to figure that out in a moment. A cable 84 meters long is cut into 2 pieces so that one piece is 18 meters longer than the other. Find the length of each piece of cable. So the first thing I did was I drew a cable that I imagined to be 84 meters long. And then you'll see that I have a little line here. That's for me to separate it from the shortest. So like I've got the shortest over here and the longest on this side, okay? Now, I have to define what both situations are. So x is considered my smaller. So x equals the measurement of the smaller piece, and x plus 18 equals the measurement of the larger piece. Well, now I just need to combine them and create an algebraic equation. So I'm going to do x plus 18 and solve for x, which you see happening right here. So this takes us down to what the smaller side is 33. Well, the smaller side is 33. And then we're going to take that 33 and plug it into x plus 18, and that gives you 51 meters. And you could even check that out. So 51 meters plus 33 meters is going to equal 84 meters, which is what we were working with from the beginning. So that ends 1-87. Let's move on. Okay, 1-88. Carlo got a pet snake as a birthday present. First of all, I would never want a pet snake for a birthday present. Nope, sorry, not me. On his birthday, the baby snake was just 26 centimeters long. He has been watching it closely and has noticed that it has been growing 2 centimeters each week. So part A here, create multiple representations, XY table graph and equation of the function for which the inputs are the weeks since Carlos's birthday and the outputs are the length of the snake. So let's take a look at a table first. Here's an XY table. We're starting with our 0 and 26 because 0 is the day, it represents the day he got it, his birthday. And then it goes up 2 centimeters every day, or every week, I should say. And so each week we add 2 centimeters to it. Can you imagine if it was growing 2 centimeters a day? That would be a crazy huge snake. All right, so let's move on. I'm going to show you the plotted points. These are the points that I plotted. And you can see at 0, 26 is where my y-intercept is. Point that out here. That's where my beginning is, and it goes up 2 every week. Then I know now that I have a line. I can have an equation because my y-intercept is 26 and my slope is 2. So I'm going to put my equation in, which is f of x equals 2x plus 26. So that's my equation for part A. Now, part B says if the snake continues to grow at the same rate, when will it be 100 meters, centimeters, 1 meter, which is 100 centimeters long? Wow, that was hard to read. How can you see this in each representation? So I set an equation up where I set the y equal to 100, and I used my rule that I came up with here. And then I just did basic algebra to solve for where x is 37. And that means on the 37th week, the snake will be 100 centimeters long. So let's take a look at the graph for that. And you can see it. I've changed the scale so that my 100 is up here. And you can hardly see down here, but this is the 37th week. So 36 and 38. So that's the 37th week. And you also see how I put it into the table. And that helps with those two parts. Moving on. Okay. 1-89 is interesting because, it's like one we did in the last homework assignment, which it said, this one says, what value of y allows you to find the x-intercepts? Well, it was the other way around. What value of x allows you to find the y-intercepts? Well, if it's an x-intercept, that means y has to equal 0. So the easiest way to do that is to replace y with 0 on each of these equations. And that's what I do. So you'll see part A first, and how we solve down to x equals -2. So that means my y-intercept is -2, 0. You go to B, you plug 0 in for the y, and it takes you down to x equals -10, so that's your y-intercept. C is pretty simple because you're just putting the 0 in, so that means x has to equal 0. So you're at the point of origin with that particular y-intercept. And then D, again, we're plugging in 0. Don't forget your plus or minus on the square root of 2. So this says plus or minus square root of 2, comma 0, but that could also be, because that means there's 2 x-intercepts. So you could say positive root 2, 0, and negative root 2, 0. So that plus or minus indicates 2 particular answers there. And the next one, we just put a 0 in again for y. We take the square root of 0 and the square root of the x minus 5 squared. And it just means that this particular problem will land on, or it'll bounce off of the x-axis. So if you graph that, you'll see what I'm talking about. Okay, and it only hits at 5, but because it's a quadratic, it's counted twice. It's 2 zeros because it hits it and bounces back up, or hits it and bounces down, depending on the sign that you have in front of your equation. All right, that is E. Move on to F. Again, you see I set it equal to 0, and then I added 13. Well, then I took the cube root of 13. And the cube root of 13 is not an even root, so you only need to say the cube root of 13. Anytime it's an even, like if it was to the 4th or to the 6th, you would have to say plus or minus. And that's a difference here. So you only have that cube root of 13, comma 0. Now you can also type in cube root of 13 and see what that decimal is as well. But that is pretty much how you solve for the x-intercepts on all of these. All right, moving on. All right, 1-90 says make a complete graph of the function h of x equals 2x squared plus 4x minus 6 and describe its domain and range. We are going to describe its domain and range first, but I also want to talk about the zeros because I know some students have problems with learning how to factor. And I want to show you an interesting thing you could do on this one to make factoring easy. So we are going to find our zeros as well, which are here. And if you're somebody who needs practice at factoring, take a look at my equation here. The first thing I did was, because they're all divisible, all the coefficients are divisible by 2, I divided by 2, which makes it so that my leading coefficient is 1, which is way easier to factor than if it would have been 2. And then I've got the diamond method here. So my A equals 1, B equals 2, and C equals -3. And you'll see that what two numbers multiply to -3, because it's -3 times 1, and add up to 2. That's 3 and -1, which you see here in my parentheses. That means x equals -3 and x equals 1, and those are my solutions. So this is -3, 0, and this is 1, 0. Okay, now let's talk about the domain and range. The domain, it's a quadratic, and so I've already talked about this before. It's all real numbers for the domain. So you're always going to have that for a quadratic. It's always negative infinity to positive infinity. The difference here is our minimum value is down at y equals -8. And it's pointing upward, so that means my range has to be y is greater than or equal to -8. And that is, all they really wanted was domain and range, but that's why I did this, because I feel it's really important to also be able to look at factoring when you have a chance. Here we go. 1-91 is next. All right. 1-91 says solve each equation below for the indicated variable. So this is just algebra practice. And so on the first one, it says solve your y equals mx plus b equation for x. So let's show you here if there's anything unusual. First, I subtracted b, and then I divided by m. And that's where you leave it at for that one. Then part B asks you to solve for the area equation for a circle and solve it for the radius. So a equals pi r squared for r. You'll see that what I did first was divide by pi, then take the square root of pi, a over pi. And you'll see that's also a plus or a minus, okay? Now, the reason it's okay to say plus or minus on this is because it's squared, but technically your radius is never negative. All right, let's move on to C, where it says solve for W. And that's actually a quick one. Basically, all you're doing is dividing by LH to get W by itself. Okay, and then last but not least, this one takes a little bit more time. You will see that first I multiplied by y, so I could get y by itself so I could get rid of the y in the fraction is what I'm trying to say. So then I distribute my y, and it's 2xy, but then the y goes away because it's essentially y over y, which is 1, equals 3y. Then I'm going to subtract 1 and subtract 3y because my goal is to get y on one side of the equation. Because I am solving for y, I want everything on one side of the equation. Then what I do here is I factor a y out of both terms because I have a y in each of those. And when I take that out, I have 2x minus 3 left in the parentheses. So then I ultimately divide by 2x minus 3. And so it ends up equaling y, well, it goes y equals, and then it's a -1 over 2x minus 3. This is one that would be good to practice and make sure you understand, because the more you expose yourself to working with fractions and how to solve for things and factor things out, the more comfortable you're going to be as we get to higher level concepts. So that ends 1-91. Remember, on this one, you can continually pause, rewind the video, whatever it is you want to do to be able to watch that equation again and solve it. So here we go. All right. 1-92 says create multiple representations, which we've been doing. XY table, a graph, and an equation of the function g of x equals 2 over x. Then make at least 3 summary statements. So we're going to start with our table. Pretend I obviously know what I'm talking about with regard to this equation and what's happening, but you'll see that I put a bunch of values in. I put all kinds of things. I put fractions. I put integers. I also put 0 so that you can see that it's undefined at 0. And then I put all those on a graph. So this is an inverse linear equation, a function, and so I've got them all plotted. I kind of know what's going to happen here. It looks like I've got a couple asymptotes at both the x and y axis, and now I think I've got my equation, which we've already been given up here. It's kind of a trick question they're saying. So my rule is y equals 2 over x, and that graphs the points. Okay, so let's look at the summary statements that I come up with. Okay, and this is what we were practicing. These are just the 3 that I came up with. You can come up with more. There's not a specific answer on this because it wants to see your summary statements about this particular function. So my first one says this is an inverse function. Domain and range are both all real numbers except 0. So domain x can't equal 0 and range y can't equal 0. Also, number 2, there are 2 asymptotes, one at x equals 0 and another at y equals 0. So a horizontal and vertical asymptote. Number 3, if x is an integer, then y will be less than 1. If x is less than the absolute value of 1, it will equal an integer. So I was looking at the patterns of my x values and what my y values ended up being. So that should hopefully help you a little bit on this problem. Let's move on. 1-93. Suppose you want to find where the lines y equals 3x plus 15 and y equals 3 minus 3x cross, and you want to be more accurate than the graphing calculator or graph paper will allow. You can use algebra to find the point of intersection. So the first thing I do is I write out those equations, and I notice that both of them equal y. So because both equal y, they equal each other. So I'm going to set them equal to each other at 3x plus 15 equals 3 minus 3x. Then I'm going to do the algebra that takes me down to x equals -2. So again, you can pause the video to check all of this out if you need to. I kind of go fast through this, but you should be able to look at it and solve it and figure out what I'm doing within this equation. Now what I need to do with that -2 is I need to plug it back into one of the equations. Doesn't matter which one, but that plugging the -2 back in will give me my y value. So I chose the y equals 3 times -2 plus 15. That takes me down to y equals 9. So my intersection point, according to my algebraic solving, is -2, 9. So now let's take a look at the graph, and it verifies that my algebra is correct. So -2, 9 is where those two lines will intersect. And that ends 1-93. So I was recording this one right around lunchtime, so I thought, oh, how fun, I will just put in a submarine sandwich, which makes me hungry, of course. The Salami and More Deli sells a 5-foot submarine sandwich for parties. It weighs 8 pounds. Assuming that the weight per foot is constant, what would be the length of a 12-pound sandwich? So I set up an equation. I like to do it this way myself. I set up, so it's 5 feet per 8 pounds. So what is the foot per 12 pounds? And so I set it up as a fraction, and then I do cross multiplication. And so that sets it up as 5 times 12 equals 8x. Then I basically divide by 8, because it's 5 times 12 is 60, divide by 8, and you get 15 over 2, or 7.5. And so your answer should say something like the sub sandwich is 7.5 feet long. And that is for a 12-pound sandwich. So that is 1-94, and we are moving on. All right, 195. If h of x equals x squared minus 5, where does the graph of h of x cross the x-axis? Let's make a sketch of the graph. So here's a sketch of the graph, but you're going, wait, I can't solve for a decimal. I don't know how to get that point. So I'm going to also show you through factoring. And you'll see that I factored this x squared minus 5 into, get something you can write and you see, x plus root 5 times x minus root 5. We call that the difference of squares. And let's take one that actually has perfect squares. So x squared minus 4. Those are two perfect squares. And I would factor that to x plus 2 times x minus 2. And so that is how you factor the difference of squares. There's a plus or minus and the square root of each term. And that's what I've done here, and I've got down to x equals root 5 and x equals -root 5. Another way you can do this one, because it's not easily factorable unless you're thinking along the lines of what I just explained, but you can use the quadratic formula. So let's do that. And on this one, my a equals 1, b equals 0, and c equals -5, so it makes it somewhat simple to solve because you're actually not having to deal with much with the zeros. So you've got this 0 and this 0, so that simplifies things a little bit. So then you have plus or minus the square root of 20 over 2, and the square root of 20 when simplified is 2 root 5. So you have plus or minus 2 root 5 over 2, which equals plus or minus root 5. And you'll see that square root of 5 does equal 2.236. So we do have a simplified radical will round to the decimals that are pointed to. Okay, and that is 1-95. Let's move on. All right, 1-96 says graph the following equations. So we do, and y minus 2x equals 3. You're going to see that what I did is I turned them into y equals, so they were easier for me to graph, okay? I want you to note here too that this particular equation, just looking at it, let me see here, just looking at it, because that 3 is on the outside of x squared, we have a vertical translation of 3 units up. Okay, this, you have your y-intercept and your slope, and you can see that my y-intercept is at 2. 3, and it does move up 2 over 1. All right, let's figure out what our x and y intercepts are for these. So the x-intercept, I've talked about this before. I'm plugging in a 0 in place of the y, and I'm solving for it. So I get x equals -3/2. So you'll see here that that is -3/2, oops, 0, okay? And then the y-intercept we already talked about. That's at 3, and that you can tell that just from the equation when we rewrite it in the terms of y. Okay, next one. There is no x-intercept on y equals x squared plus 3 because the minimum point we've already talked about is at 0, 3. And that is the y-intercept. So that's pretty simple when it comes down to those. And let's move on. So the next question was, where do these intersect? Where do these two particular graphs intersect? And so the first thing I did was set them both equal to y, which you can see here. I've just rewritten them so they're in terms of y, just like I did on the previous slide. And then I'm setting them, because they both equal y, so they equal each other, I'm setting them equal to each other and solving down. Now, when I do that, I get down to where I have to factor. So I'm factoring x out of the equation, and I get x, and then times x minus 2. So that means I have two x values. So what I need to do is plug those x values into each equation to solve. So I have plugged a 0 in here, and that gets me down to 3. Same here, I plug a 0 in there, and that gets me down to y equals 3 as well. And I'm using both equations. This one, I'm plugging in a 2, and it gets me down to a 7. And that's the same thing that's happening here. I plug in a 2, and I get to a 7. So that means they are intersecting at 0, 3, and 2, 7. So let's check out our graph. And there you have it. Those are the 2 points that we have graphed in this particular problem. And that also, in summary, the points of intersection are 2, 7, and 0, 3, which we have talked about. We're moving on. So this is the final problem on 1.2.2, and I love this Desmos activity that they actually have in the assignment. So if you get a chance and you see these Desmos links, use them. They're really helpful. I like this one because you get to play with technology and you don't have to write it all out, and it makes it a little more fun than just, writing everything down. Okay, so the first thing I'm going to do on this, I love matching problems, and I don't always start with number 1. I look at what I'm trying to match, and I look and see if I can eliminate, some of the choices. So the first thing I did is I scoped down here, anyway, came down here and I saw number 3 and 4 were Pythagorean theorem and quadratic formula. Well, we use those a lot. So those are pretty easy to find. And this little monstrosity up here we know is the quadratic formula. So I'm just going to drag my point up there. And when I get close to A, it tells me I'm correct. And then I also know that this is the Pythagorean theorem because I use it all the time. And so I'm going to go ahead and do that. So now it's just a process of elimination. And I know that a lot of people didn't learn law of sines and cosines last year. So it's like, trying to figure it out, you have to do some educated guessing. And my first thing is to look at those. I see sine in this particular problem, and I see cosine here. I see law of cosines and law of sines. Well, I don't know that they're going to call something law of cosines and put sine in it. So I'm going to go ahead and just see if I'm correct. Well, I am correct, which means also that law of sines is B. And that ends this. Again, use those Desmos activities. They're actually really awesome. And I'm moving on. Well, again, thank you so much for watching one of my videos. I really, really hope that if you like this video that you'll consider subscribing to my channel, and that way you get notifications of all the other videos that I'm coming up with. And then a thumbs up would be nice as well. So we'll see you on the next video. Take care.